So for cos, we're going to input the exact same radians as we did for sine. So we're going to input 0, pi halves, pi, 3 pi halves, and 2 pi. We're going to do it starting the exact same way that we did sine. So because we're doing it the exact same way we did sine, I'm going to go ahead and draw my x and my y axis. The same way. So I'm going to count 1, 2, 3, 4, put a pi, 1, 2, 3, 4, put a 2 pi, and then I'm going to put 1, -1, okay. And I just want to see how this graph is different than the sine graph. I told you guys that when you graph multiple of like the periods of the graph and then stand back and look at it, it looks exactly the same as sine. Yesterday I told you guys that it looks the same, but that when you start it, it looks different. So we're going to see that today. We're going to start it, it's going to look different, but then if you draw multiple curves on the same graph, you're going to see like, oh, it's the same thing as what we did yesterday, basically. So let's look at the graph. Now, yesterday when we did the sine curve, we were using the y coordinates. Today we're doing the cosine curve, so which coordinates are we going to use? We're going to use the x coordinates. So if we did cos of 0 radians as our input, cos of 0, what would our output be? It'd be 1 because we're going to use the x coordinate today. Okay, so it'd be 1. All right, cos of 0 is 1. All right, next we're going to do cos of pi halves. What would cos of pi halves be? 0. Cos of pi halves would be 0. Okay, next we're going to do cos of pi. Cos of pi is -1. Okay. Cos of 3 pi halves is 0. And then cos of 2 pi is 1. Okay? And then if we wanted to continue the pattern, we could say 2.5 pi, and then 3 pi, and then 3.5 pi, 4 pi, 4.5 pi, 5 pi, 5.5 pi, 6 pi. We could keep going around as many times as we wanted to keep the graph going. Okay, so what we're going to realize is that when we draw a cos graph, instead of starting and ending at 0 like a sine graph did, a cos graph starts at 1 and ends at 1. So that's different. So cos graph starts at 1 and ends at 1. Starts at 1, ends at 1. Okay? A sine graph usually starts at 0, ends at 0. It usually hits 0 in the middle. A cos graph starts at 1, ends at 1, hits -1 in the middle. So in the middle, we're going to dip down to -1. And then, of course, for you to be able to get from +1 to -1, you have to cross 0. So in the middle of those two, we're going to cross 0. In the middle of these two, we're going to cross 0. Okay? And then we're going to make sure that we have our U shapes. So for these 2 points, we have half of a U. For these 3 points, we have a full U. And for these 2 points, we have half of a U. So that's what one period of a cos graph looks like. And then we just draw more periods of the graph. So now I'm going to count 1, 2, 3, 4. There's 3 pi. 1, 2, 3, 4. There's 4 pi. And I'm going to do the pattern again. So I'm going to start at 1. I'm going to end at 1. In the middle, I'm going to dip down to -1. Between the first two 1s and -1s, I have to cross over 0. Between the second two 1s and -1s, I have to cross over 0. And then I'm going to draw half of a U shape, a full U shape, and half of a U shape. And then I can keep it going over here. So 1, 2, 3, 4, there's negative pi. 1, 2, 3, 4, there's negative 2 pi. We start up at 1, we end up at 1. In the middle, we dip down to negative 1. Between the first two 1 and negative 1s, we cross over 0. Between the second two 1 and negative 1s, we cross over 0. We get half of a U shape. We get a full U shape. And then we get half of a U shape. So now when you stand back and look at it, does it look the same as yesterday? Yeah. But if you look at just the very beginning of it, it looks totally different, right? Because it starts differently than the sine does. The sine looks like this. Or I guess it looks like that. There's the sine. That's what the sine looks like. The cos looks like this. So they look a little bit different when you start them, but then when you graph the whole thing multiple times, they look exactly the same. All right, so if we look at this, we still have the amplitude is still the same thing. From the middle of the graph, these go up by 1 or they go down by 1. So the amplitude is 1 for a typical cos graph. It still has a period of 2 pi. So it's still normal for the to get all the different pieces of the graph on a unit circle from 0 to 2 pi to get all the points. And that can still change if you have another b value. The graph still goes left forever and right forever. For all of the graphs, you're never going to have one that doesn't unless they did it on purpose and they stopped the domain for some reason. The range for the regular graph is still going to be -1 to +1. So all that stuff is still the same. Now, if we do the transformations, I'm going to say y equals a times cos of b times x minus h plus k. The h tells you how far the graph goes from to the left or to the right. Positive moves you to the left, negative moves you to the right. Just like yesterday with the sine curves, we are not going to deal with left and right shifts. In Math 3, that's a Math 4 or pre-calc concept. The k moves the graph up or down. Positive for up, negative for down. The b value changes the period of the graph, just like it did for sine. So to find the new period of the graph, you're going to do 2 pi divided by b. And then the absolute value of a is the amplitude of the graph. Amplitude is always positive. It's just saying how far from the middle of the graph are you. If a is negative, then the graph has been reflected over the x-axis. Okay, so I think that's all the transformations, just like we did yesterday. Any questions so far? Brains are okay? All right, so if we look at example 1, y equals cos 3x, there is not a number in front of cos. So what is the amplitude? 1. Amplitude is 1. The b value is 3, so what would the period of the graph be? 2 pi over 3. 2 pi divided by 3. Okay, so I'm going to go ahead and draw my x and my y axis. And whenever we draw along the x-axis, we're always going to do every 4 boxes, 8 boxes, or 12 boxes. What would you guys prefer? 4? So we're going to do 1, 2, 3, 4, and put 2 pi thirds. 1, 2, 3, 4. Another 2 pi thirds makes 4. 1, 2, 3, 4. Another 2 pi thirds would make 6 thirds, which is just 2 pi. Okay. For an amplitude of 1, we can do 1, 2, or we could do 1, 2, 3, 4, or we could do 1. What's your guys' preference? 1, 2, 1, 2, 3, 4, 1, 1, 2. Okay, we'll do 1, 2. And so then I'll do 1, 2 down here also. Okay, so since this is a cos graph, do we start at 0 and end at 0, or start at 1, end at 1? Start at 1, end at 1. Okay. Then in the middle, we're going to dip down to -1. Between the first two ones, we cross 0. Between the second two ones, we cross 0. And then we could do it again. We start at 1, we end at 1. In the middle, we dip down to -1. Between the first two ones, we cross 0. Between the second two ones, we cross 0. And we can get our U shapes in there. So start at 1, end at 1. In the middle, dip down to -1. Between the first two ones, we cross 0. Between the second two ones, we cross 0. And then we got half a U right here, half a U right there. Okay, what is our domain? Yeah, forever left, forever right. Okay. And what's our range? -1, 1. Perfect. Okay. Other side. All right, what is the amplitude for this one? 2. Okay. How about the period for this one? Pi over 2. So if we want to show our work with that, it would be 2 pi over the b value, which is 4, and then 2 over 4 simplifies to 1/2. So pi halves. Okay. All right, do we want to do 4 boxes, 8 boxes, or 12 boxes? 4. All right, so I'm going to do 1, 2, 3, 4 for pi halves. 1, 2, 3, 4 for 2 pi halves, which is pi. 1, 2, 3, 4 for 3 pi halves. Okay. For the amplitude of 2, do we want to do 1, 2, Do we want to do 1, 2, 3, 4? What do you guys think? 1, 2? Okay. 1, 2, 1, 2. Okay. All right, so since we're doing a cos graph, are we going to start at 2, end at 2, or start at 0, end at 0? Start at 2, end at 2. Now, a normal cos graph would start at 2, end at 2, but this is a negative cos graph. So what are we going to do? Start at negative 2. Start at negative 2, end at negative 2. Then in the middle, what are we going to do? So yeah, so normally you would go down, but instead we're going to go up. Go up to positive 2, okay? And then what do we do? Between the 2's, we cross 0. Between the 2's, we cross 0. Okay? So we're going to start at negative 2, end at negative 2. In the middle, we go up to positive 2. Between the 2's, we cross 0. Between the 2's, we cross 0. Start at negative 2, end at negative 2. In the middle, we go up to positive 2. Between the 2's, we cross 0. Between the 2's, we cross 0. All right, here is our U shape. And there's our U. And our U. Half of a U. Half of a U. Okay. So what is the domain? Okay, easy domain. What's the range? Okay. Ta-da. All right. What is the amplitude for number 3? 1. Anyone know the period for number 3? Not 2 pi over 3. What is it? It's not pi over 3. It's 6 pi. Okay, so how do we get 6 pi? We got to keep, change, flip. Okay, so this we would have to rewrite. Let's do that since this is our notes. It would be y equals negative cos, and then the number in front of x is actually a 1/3. X divided by 3 is the same as 1/3 x plus 2. So the b value is 1/3, and then what we did to find the period of the graph is we did 2 pi divided by 1/3. And then since we were dividing by a fraction, we had to keep, change, flip. That's how we got a period of 6 pi. 6 pi total, yeah. Does that make sense? 6 pi? Okay, period of the graph is 6 pi. All right, I'm going to ask it. I already know the answer. Do we want to do 4 boxes, 8 boxes, 12 boxes? 4 boxes, I'm shocked. Okay, let's do our 4 boxes. Okay. 1, 2, 3, 4, 6 pi. 1, 2, 3, 4, 12 pi. 1, 2, 3, 4, 18 pi. 24. Oops. Okay, so this one has an amplitude of 1, but the whole graph does shift up 2. So, are we going to do 1, 2, or are we going to do 1, 2, 3, 4? 1, 2, or 1, 2, 3, 4? Now, if we do 1, Yeah, if we do 1, 2, what's going to happen? Our midline is going to be at the very top, right? And then we're going to have to, from the midline, have an amplitude of 1. Does that make sense? So we can't do 1, 2. I mean, you could, but then you're going to have to draw half your graph off the graph. Does that make sense? So for this one, we're going to have to do 1, 2, 3, 4. Okay. So I'm going to do 1, 2, 3, 4. 1, 2, 3, 4. Okay. And how do we do the ones with a midline? Put a dotted line at 2. Okay. Okay. Are we, so to graph the coast graph, are we starting at the midline, ending at the midline, or are we starting above or below the midline, ending above or below the midline? Yeah, above or below, because we're doing a coast graph. Now this is a negative coast graph, so should we be above the midline by 1 or below the midline by 1? We should be below the midline by 1. So I'm going to start below the midline by 1, and I'm going to end below the midline by 1. Start below, end below. Okay? And then what am I going to do in the middle? I'm going to go up by 1. Okay? And then what am I going to do between these two? Cross over, hit the midline. And then what am I going to do between these two? Hit the midline. Okay. Let's do it again. So I'm going to do below the midline by 1, below the midline by 1. What am I going to do in the middle? Go above by 1. Okay. Now what do I do? Yeah, hit the midline, hit the midline. Okay. So I've got below, below. In the middle, what should I do? So I was below, below. In the middle, go above. And then what do I do? Hit the midline, hit the midline. Okay, I got my U shapes. All right, my domain is negative infinity to infinity. My range is 1, 3. Okay. All right, what is my amplitude for the next one? 2. What's the period for the next one? 12. Everyone get that? What's the period for the next one? How do we get it? Keep, change, flip. Yeah, we got 2 pi divided by pi 6. And we have to keep it, change it, flip it. And the pi's cancel. 2 times 6 is 12. Okay, I want you guys to finish this graph. Finish number 4.